What would you do if you discovered that the entire universe might be lying to you? What if the greatest scientific tool ever created by humanity had just revealed something that simply shouldn't exist? Something so far removed from any accepted theory that it forced scientists worldwide to question everything they knew about the origin of reality. A single image, a single set of data. And suddenly, nothing seemed to make sense anymore. Because the James Webb Telescope didn't just observe the cosmos, it debunked it. And what it found raises a question no one was prepared to ask. What if the universe isn't natural? What if it's the result of something much older, much more intelligent, and much more deliberate than we ever dared to imagine? Since its launch in 2021, James Webb has become humanity's most powerful window into deep space, allowing us to see further into the future and deeper into the cosmos than any other instrument ever built. Its purpose has always been to answer the oldest questions of existence. How did it all begin? How did the first galaxies arise? Are we alone? For years, it delivered stunning images and groundbreaking data, confirming theories, refining models, and expanding our understanding of the universe. But now something has changed. Webb is no longer just confirming what we know, it's challenging everything. It all began with a seemingly ordinary observation, a deep space scan in search of the earliest cosmic structures. Nothing seemed out of the ordinary until the data began to be analyzed. It was at that moment that astronomers realized they were looking at something that simply shouldn't be there, something too big, too old, and too organized to exist at that stage in the universe's history. When the images were processed, silence fell over research centers around the world. In early 2025, Webb pointed its mirrors at a region known as the Cosmic Dawn, a period shortly after the Big Bang when the first stars and galaxies should have been just beginning to form. What was expected were thin clouds of gas, unstable structures, and primitive clusters. But instead, the telescope captured images of fully formed, massive, organized, and bright galaxies, some as large as our own Milky Way, existing only 200 million years after the birth of the universe. In cosmic terms, this is less than a blink of an eye. According to all known models, this type of structure would take billions of years to form. But there they were, mature, perfect, and utterly impossible. If that already seemed inexplicable, the following data made everything even more disturbing, because it wasn't just a galaxy out of place. It wasn't an isolated error, it was a pattern. And the more Webb observed, the more this pattern repeated itself, as if the universe itself were trying to communicate something, or hide something, in plain sight. Analyzing the SMACS 0723 cluster, scientists noticed something even stranger. Points of light, organized in geometric formations, spaced with almost perfect precision over millions of light years. Galactic evolution, according to everything we know, is chaotic, shaped by random collisions and unpredictable gravitational forces. But these points formed symmetrical structures, like cosmic grids, repeated in multiple observations. In another region, a spiral galaxy called JD's GSZ140 presented rotational patterns impossible to explain, with arms spinning too fast, as if under the influence of an invisible, unknown force, not predicted by any existing gravitational theory. And then came something even more perplexing. Something that not only challenges our theories, but challenges our very understanding of how planetary systems can exist. While observing a star system about 200 light-years from Earth, known as TOI 715, Webb detected a planet called TOI 75c. This world has approximately 12 times the mass of Jupiter, orbits its star at a distance greater than Pluto's from the Sun, and yet belongs to a system only 10 million years old. There is no visible protoplanetary disk, nor enough gas or dust to explain how such a massive planet could form there, so far away and so quickly. Even stranger, its atmosphere contains heavy elements that theoretically should only exist after billions of years of stellar evolution. In other words, this planet shouldn't exist. And yet, it's there, defying everything we know about planetary formation and cosmic evolution. Faced with this, researchers began to raise hypotheses they never imagined considering. What if this planet hadn't formed there? What if it was a relic of a much older system, somehow transplanted into this new environment? Or something even more unsettling. What if it had been deliberately placed there? The anomalies didn't stop there. In an observation of the ultra-deep field, Webb captured a gravitational lens centered around a galaxy called GZ 987. Gravitational lenses are rare but known phenomena. What no one expected was to find a perfect ring, a continuous halo of light with extreme mathematical precision. For this to occur, the alignment between the galaxies involved would have to be almost absolutely exact, on a scale of billions of light-years. The statistical probability of this happening is so low that, according to the models themselves, it is practically impossible. And yet the ring was there, perfect, symmetrical, defying everything we know about space-time and gravity. But none of these discoveries compare to what came next, because this time it wasn't an out-of-place galaxy, it wasn't an impossible planet, it wasn't an improbable symmetry, it was something that seemed intentional. During a deep field scan in a region considered empty, Webb detected a series of rhythmic light pulses. They weren't stars. They weren't quasars, they weren't pulsars. They were fluctuations too weak for any known source, but too regular to be random. The pulses repeated every 11.7 seconds for 48 hours, and then ceased abruptly. There was no visible source in the area, no thermal signature, no immediate natural explanation. All systems were checked, all data reviewed. The pattern remained, a signal with no visible origin, no identifiable cause, but with a precision that defies any known astrophysical phenomenon. The question became inevitable. What if this isn't a natural phenomenon? What if it's not noise? What if it's a signal? Looking at all these discoveries together, one thing becomes clear. We are not facing isolated errors, but a growing pattern of impossibilities. Galaxies matured too early, massive planets where they shouldn't exist, symmetrical structures where there should be chaos, regular pulses with no visible source. The James Webb Telescope was designed to observe the universe's past, but ended up revealing something about its present, and perhaps about something much older than time itself. The Big Bang model states that everything began 13.8 billion years ago in a chaotic explosion of energy. But if galaxies were already fully formed just 200 million years later, if structures show extreme organization, if signals emerge without apparent cause, then perhaps the Big Bang is not the absolute beginning. Perhaps it is only the most recent chapter in a much longer story. Some researchers have begun exploring a radical idea, the possibility of a cosmic memory. In multiple observations, clusters of galaxies appear to repeat structural patterns, as if the universe were echoing forms from the past. What if space-time itself is not just a passive stage, but a medium that stores information? What if dark matter, considered invisible and inert, actually carries gravitational imprints of ancient structures, shaping the future of the cosmos? This hypothesis suggests that the universe may not only be evolving, but remembering. But there is an even more disturbing possibility, because in another observation, Webb detected a gravitational distortion where there should be absolutely nothing. In a region far from any visible galaxy, Webb observed a gravitational lensing effect with no detectable associated mass, no stars, no black holes, no visible concentration of matter, just a curvature in space, as if something massive were hidden there. While these effects are usually attributed to dark matter, this distortion was too intense, too localized, almost as if it were being caused by an object with defined boundaries. Some physicists began to raise bold hypotheses. What if this isn't dark matter? What if it's the remnant of something built, an ancient invisible structure, still warping space after billions of years? If this is true, then we are not just observing the universe. We are observing traces of something that was here before. The James Webb Telescope has always been about discovery, about revealing the unknown. But now, it's doing something even more profound. It's forcing humanity to confront the possibility that we are not merely observers of the cosmos, but participants in a system far older, far more complex, and far more deliberate than we ever imagined. Impossible galaxies, planets that defy logic, signals that suggest organization, intention, perhaps even intelligence. These are not random noises. They are real, measurable data that challenge the very structure of our reality and call into question everything we believe to be immutable. What if these patterns are real? What if these signals are deliberate? Then the deeper question ceases to be what exists in the universe and becomes, what is humanity's role within it? Are we truly alone? Or are we only beginning to realize that the cosmos may be much more than a collection of particles in random motion? Perhaps Webb has not only found traces of the past. Perhaps it has revealed a system, a map, or even a message waiting to be deciphered. Now the question is yours. What do you believe the James Webb Telescope has actually found? Are these discoveries the first signs of cosmic intelligence or just natural phenomena not yet understood? Write your opinion in the comments. And if you want to continue unraveling the greatest mysteries of the universe, subscribe to the Mysteries of the Universe channel and activate the bell. Because Webb's next discovery may not only change what we know about the past, but about the future that is already written among the stars.